In talking about whether or not genetic information suggests an intelligent designer, evolutionists will often refer to the paper on information theory by Claude Shannon, called a mathematical theory of communication. They use it primarily to attack the idea that random mutations reduce genetic information. However, it turns out that they are confusing statistical information with complex specific information. Shannon's paper is a paper that is frequently used to claim that information does not need an intelligent source. It was a mathematical description of the transmission and storage of information. It does not deal with information content. In other words, this paper deals exclusively with statistical information which may or may not have any meaning. Complex specific information, on the other hand, has specific meaning and is only known to be the result directly or indirectly of intelligence. Complex specificity, by its very nature, requires deliberate intent, and thus is evidence of intelligence. It is scientifically mathematically defined as an object or event whose probability is less than 1 in 10 to the 150th power, where 10 to the 150th power is the maximum number of possible events in the entire history of the universe, assuming the Big Bang. Thus, any form of encoded information with a probability of less than 1 in 10 to the 150th power would have to be considered complex specific information. For anything written on a standard PC keyboard, that would be any text consisting of more than 75 characters. Now, in practical terms, any text written by a human being with deliberate meaning would be complex specific information, but this is a specific mathematical definition. Now, the human genome has about 25,000 protein encoding genes that actually produce about 1 million different proteins. Now, because the average protein has a length of 300 amino acids, each of which is encoded by 3 nucleotides, we have an average length for these genes of 900 nucleotides for a total of 22.5 million nucleotides, each which can be any one of 4 nucleotides. This results in a statistical probability of 1 in 6.4 times 10 to the 13,546,349th power, which is more than 13 million orders of magnitude larger than the limit. Even if you assume that there are 1 billion possible alternative proteins that would work and produce the same results, you will still have odds of 1 in 6.4 times 10 to the 13,546,340th power, which barely puts a dent in it, while actually being an impossibly exaggerated large number of alternative proteins. This just includes the protein encoding genes, and not the entire human genome of 3 billion nucleotides. Consequently, by definition, the human genome qualifies as complex specific information, not just statistical information, so random changes can decrease the complex specific information of a genome, while supplying evidence for intelligent design, because such information is only known to be the product of intelligence, even if indirectly. In conclusion, the difference between statistical information and complex specific information is that statistical information simply deals with the transmission, reception, and storage of information without regard for its content. Complex specific information, on the other hand, deals with specific range arrangements within statistical information and includes the meaning of the content. Specific complexity, and so complex specific information, is defined not just by the existence of meaning, but by their extreme improbability.